Okay, this is going to be a video for homework help for 6-3, just to kind of get you started. Hopefully, as you work through the lesson, the big idea that you got was this definition of a logarithm. It's just a rewrite. It's nothing, it's just a logarithm is just a different way to write an exponential. And you're pretty familiar with exponential functions that look like this. So you just can rewrite it in log form. And so basically, I like to use b for base, and then a is the argument, we say. That's like what you're taking the logarithm of. And then x is your exponent in the original. So a lot of times they'll say things like, what is a logarithm? Well, it's just a different way to write an exponent. So that's the basics. And then the other thing about this is that e, that base that we came up with, that special number 2.7 something, is a special base, and it's called a natural base, and it goes with a natural logarithm. So whenever you see ln, it's just a different way to write log base e, and e is that special number 2.7 whatever. So I started with number 14 here. So number 14 had, the original problem was 16e to the t power equals 98. This is just like number one, problem number one in the homework, I think, but they're numbered like 6.3.14, so you might see this one. Anyway, our goal is to get t alone, and that's the beauty of logarithms, is that you can get an exponent down. So first thing you do is isolate the exponential piece. So the first thing I was going to do is divide by 16, and that gave me e to the t equals 6.125. And then I just, whenever you're at this point, when you want to get an exponent down, you rewrite it as a logarithm. So it was log base e, because remember the base becomes the base of the logarithm. Whatever it equals goes in the argument spot, and then it equals t. And then that, remember, log base e is a fancy way to write ln. And I tried this online, and I typed this in, and it said, please write it in a different form. So I just had to type in exactly that, 6.125. So you may get a similar problem. You might not get exactly the same problem, but something like that. If you did want to find the actual value of something like this, we use Desmos just because it was handy on the computer. And you just have to hit the function button down on the keyboard with the numbers, and then choose miscellaneous, and you'll find the ln logarithm buttons. So that was number 14. Another one I wanted to show you was jumping ahead to 19 here. And again, you're going to get it. You might not get exactly the same numbers, but a similar problem to this. So it says find the inverse. And from section 5.6, we know that inverse means you switch x and y. So I had y equals 4 to the x. I rewrite that as x equals 4 to the y. And once again, I want to get that exponent down and isolated. So I use the definition of a logarithm. So this and this are the same thing. The base is 4, so that's the base of my logarithm. X is what it equals, so that's the argument. And then y is the exponent, and that becomes the lone term. So this is the inverse of that. So that was 6-3, number 19. And then number 40, I just wanted to quickly mention because that just says use a calculator. And again, you can find that on Desmos if you want to, or just on any calculator. If you turn your iPhone sideways, there's a log button there. And you just type in log, and then make sure in parentheses 0.24. And what I wanted to point out is that the directions say it needs to be accurate to the 10,000th, which is 4 decimal places. So I had to type in negative 0.6198 to get it right. Again, I don't even know if number 40 is assigned, but just right in that region, those type of problems, you have to be so accurate. The last one I wanted to look at with you is number 45. And these are a lot like example 5 in the exercise, in the examples and try it. So it'll be something like this. The first thing to recognize is that if there's no base written down below here, then it's just default base 10. So I just rewrote that with a base of 10. And then I just rewrite this in exponential form because that's something I'm familiar with and I know how to solve. So I'm going to write 10 as the base to the 3 power equals 7x plus 6. So it looks like that. So I rewrote it in exponential form, and then I know that 10 to the third is 1,000. And then this is something basic that you can definitely solve. 1,000 equals 7x plus 6. So I just subtracted 6 and then divided by 7 and got number 1. We got x equals 142. That's just kind of a random sampling of the questions from 6-3. You feel free to present more of these on our Flipgrid, and more instructions will be coming about that, but this should get you started. Thanks. Have a good day.